Have you ever stopped to think about how the internet works so well, even with billions of people and devices connected at the same time? Behind this speed lies a massive transformation, one that happens almost invisibly within telecommunications networks. And one of the key players driving this change is the telco cloud. In simple terms, telco cloud is when operators use cloud computing technologies to run their networks. This means that functions such as authentication, routing, and traffic control, which once relied on dedicated physical equipment, are now performed on cloud servers, often hosted in private data centers. This shift gives operators greater flexibility, allowing them to automate processes and scale services more efficiently, all without compromising performance or security. But this transformation didn't start overnight. At first, networks evolved from the traditional model, based on proprietary hardware, to something more flexible, with NFV, Network Functions Virtualization, which virtualizes network functions, and SDN, Software-Defined Networking, which separates the network control from the physical layer. Now, we're entering the next phase: cloud-native networks, systems built from the ground up to run in the cloud. This brings more modularity, automation, and agility. This shift is essential for networks to keep up with growing challenges such as 5G, the use of artificial intelligence, and edge computing, which, in simple terms, means spreading smaller branches of the cloud across different regions to process data closer to where it's generated. In the next few minutes, we'll explore the 5 pillars of telco cloud evolution and how they are shaping the present and future of telecommunications networks. Shall we? Telco cloud starts with 2 central ideas: cloud native and automation. Cloud native means creating applications with everything the cloud offers in mind, such as easy scaling, rapid updates, and good fault handling. This is possible using microservices, containers like Docker, and tools like Kubernetes, which organize and distribute these services. In practice, operators are moving away from large blocks of software and towards running smaller, more flexible functions in containers. This allows them to distribute their networks more efficiently, including in smaller locations at the network edge. But all this flexibility needs automation to work well. That's where tools like DevOps, CI/CD, and GitOps come in. They allow services to be tested, updated, and deployed automatically, without requiring so much human intervention. As a result, networks become faster, easier to maintain, and ready for the challenges of 5G, artificial intelligence, and edge computing. Beyond the software, the telco cloud is also changing internally, in the hardware itself. Previously, everything ran on servers with standard CPUs. Today, operators are using specialized accelerators for more demanding tasks. For example, GPUs for artificial intelligence, DPUs, and IPUs to improve security and network connectivity, and smart NICs that accelerate traffic directly on the network card. These components improve performance, reduce power consumption, and free up the CPU for more important tasks. But caution is needed. If the operator uses very closed hardware, it may end up locked into a single vendor. Therefore, initiatives like the OPI are creating open standards so that these accelerators work with different systems, guaranteeing more freedom of choice in the future. With so many servers in operation, saving energy has become a priority. Even when idle, these devices consume a significant amount of power. Therefore, operators are adopting green IT practices, that is, reducing consumption without sacrificing performance. Current processors already help with this. They use modes like C states and P states to asleep when idle or run slower when they don't need as much power. And the great ally in this process is artificial intelligence. With reinforcement learning techniques, systems learn to balance performance and consumption in real time, intelligently adjusting resources. It's automation helping to save energy. In addition to reducing costs, this helps operators achieve sustainability goals that are increasingly demanded worldwide. Finally, security. In telecommunications, this is a non-negotiable pillar. With networks running in the cloud, it's necessary to protect much more than just the software. Security now begins with the hardware, extends through initialization, and encompasses all processes. One example is the Shura project, which creates processors capable of preventing memory attacks, such as buffer overflows. Another layer of protection comes from trusted execution environments, such as TPM and Secure Boot, which ensure that the network software has not been altered by intruders. This verification is even more important in the telco cloud, where functions from multiple vendors run on the same infrastructure. And, in many countries, such as the United Kingdom, this is already required by law. In the end, the telco cloud needs to be not only agile and efficient, but also reliable and secure from the first bit to the last data packet. As we approach the end, we realize that telco cloud is not just an evolution, it's an ongoing revolution in telecommunications networks. Back then, it all started with the virtualization of network functions, with concepts like NFV and SDN. Today, this evolution has gained momentum with the adoption of cloud-native technologies, intelligent automation, artificial intelligence, and new security strategies. In this video, we saw 5 pillars that support this transformation: cloud-native and automation, hardware heterogeneity, energy efficiency, secure computing, and the entire journey of operators adapting to an increasingly challenging scenario. These pillars are not just technical topics. They represent a change in mindset, a new way of operating networks, where flexibility, performance, security, and efficiency need to go hand in hand, without compromising the quality of the services we use every day.